Ignition sequence start. 5, 4, 3, 2, 1. Liftoff. We have a liftoff.
Good afternoon, ladies and gentlemen. Welcome to the Mitchell Institute's Schriever Spacepower series. I'm Charles Galbraith, Senior Resident Fellow for Space Studies at the Mitchell Institute's Spacepower Advantage Center of Excellence. Launch and the assured access to space that it represents is foundational to space superiority and leveraging the unique benefits of the space domain. Let's face it, if you can't get to space, you can't control it. Getting to space is often challenging, though. It is, after all, rocket science. Thankfully, a team of highly skilled experts and dedicated launch providers are constantly working to assure our nation's access to space. That's why we're thrilled to welcome Brigadier General Kristin Panzenhagen, who leads the U.S. Space Force's core competency of space mobility and logistics. Her and her team secure reliable and responsive launch services to deploy the space-based capabilities needed by our nation's warfighters, intelligence professionals, decision makers, allies, and partners. Additionally, they operate and sustain resilient and ready launch and test infrastructure to project on-orbit warfighting capability through all phases of conflict and to expand U.S. economic, technological, and scientific leadership. Further, assured access to space delivers servicing, mobility, and logistics capabilities that operate in, from, and to the space domain. Among General Panzenhagen's many roles are Program Executive Officer for Assured Access to Space, Commander, Space Launch Delta 45, and Director of the Eastern Range. She also serves as the Space Force University Partnership Program co-champion for Purdue University. Brigadier General Panzenhagen, thank you so much for being here. Welcome to the Schriever Spacepower series. Before we launch into questions, let me turn it over to you for any opening comments.
Thanks. So first, thank you for having me, and thrilled to be here and get to talk to you and the folks that are tuning in for this.
It's our pleasure.
It is a really exciting time to be in space mobility and logistics between the innovation that we're seeing with industry and the ops tempo picking up and the Space Force's emphasis on space superiority right now. We are extremely busy, but we are really pushing the bounds on what we've done before, so I'm excited for the conversation.
Great, thank you. So there are multiple paths to get to orbit, and it depends on what your mission requirements are. You might need a small booster or a medium or a heavy booster, and where you're launching to, what orbit, that all has an impact on what provider you go with and what approach you take. So can you describe for us the different programs or lanes that help constitute our assured access to space?
So we've got a couple different programs and then a variety of contracts within those programs. We're called Assured Access to Space for a reason, because we will assure that our nation can reach anywhere that it needs to get to in space to put those important payloads in orbit. So the smallest program that we have would be the Rocket System Launch Program. When I say small, I'm talking about more the size of the rockets in that case.
Yep.
So they start out from smaller rockets that are suborbital. So if you think sounding rockets, experiments, targets.
Okay.
And then within that program, we also have orbital capabilities, again, with the smaller rockets usually, sometimes ranging larger, but smaller rockets about 400 pounds or larger to orbit, mainly looking at low Earth orbit for that.
Okay.
Then we move to the National Security Space Launch Program, and that's where we have our medium to large lift capability. So we have 2 active contracts in that program right now. Phase 2 is what we call the first one. So those are launches that we awarded in fiscal years 20 through 24.
Okay.
And then Phase 3 started in 25 and is still going. We're still launching the Phase 2 missions as well as getting ready for the Phase 3 missions in the next couple of years. So that launch capability, I mentioned it's medium to large, so we're looking at a minimum of 15,000 pounds to LEO.
Okay.
But it's not just to LEO, so we cover all of what we call 9 reference orbits for that, so everything that we would need to get to for national security purposes, from LEO all the way up to the most difficult orbits with direct inject to GEO.
Okay, no, thanks for that breakdown. So there's also an element of risk management associated with launch, and some launch providers have a proven track record and some are just starting out. And as we know, launch can often be a challenging endeavor. So can you describe a little bit of the mission assurance or the risk management approach that you all take?
Yeah, so defining the risk is really something that we've tried to lean into and optimize with this Phase 3 contract for National Security Space Launch. The first thing that we do is determine what the risk tolerance is, or the acceptable level of risk that satellite can take. We don't do that just in our program office.
Okay.
You know, we're talking to the satellite program offices. We're talking to the folks that do force design and operations within the Space Force or with mission partners. So we're looking at things like how mission critical is that capability on orbit? Are there other copies of that satellite ready to go? Is it being actively produced? How expensive is it? All of these things to try and figure out, is this something that is a, cannot fail type of mission, or is this something where we can take more risk? So the way we tackle that, once we've figured out what the risk tolerance level is for the payload, is there's different places that we can put it within the contract. So for those no-fail payloads, we have what we call Lane 2 within this Phase 3 contract. Try to make it confusing with a lot of numbers in here.
OPSEC.
So Lane 2 is, first of all, we do a full certification for the launch vehicle. And when I say launch vehicle, I mean the family of launch vehicles, not the individual launch vehicle in this case. So for the certification, we, the government, are partnering with the launch service provider, and we are validating the design of the vehicle, the manufacturing processes that they use, the logistic procedures, the pad configurations, as a baseline to make sure that the vehicle can do what it needs to do. It can do it for all 9 of those reference orbits. It can do it from either the eastern range or western range. So once we do that launch vehicle certification, you mentioned mission assurance. So we do mission assurance for every Lane 2 national space security launch that we do.
Okay.
And mission assurance consists of looking at any variations from that baseline certification. So if there's been a change in the rocket fleet, we'll validate that technical change and make sure that's still going to work. We'll look at the pedigree of the components on that rocket to make sure there's no added risk there. Look at any open work, make sure that's on path to close. We observe a lot of the tasks that are happening physically with the rockets. We will oversee the moves, and then we will sit on console during the count and during launch to assess the data.
Wow.
Now, so that's for our least risk tolerant missions.
That's right.
So now as we go towards more risk tolerant, that's where we get into what we call Lane 1 of this Phase 3 contract. And to make it even more confusing, Lane 1 has 4 tiers within it that goes from Tier 0 to Tier 4. But these tiers are the varying levels of mission assurance. So Lane 1 does not have the certification requirements that Lane 2 has for the baseline vehicle.
Okay.
For Lane 1, the vehicle just has to have had 1 successful flight.
Okay.
And then for the varying tiers of mission assurance, Tier 0 is essentially the government is hands-off. It's a FAA licensed launch. And then marching your way up to Tier 3. Tier 3 is fairly substantial mission assurance, but still less than what we would have seen on those no-fail missions on Lane 2. So we have a pretty wide variety when we look at the Phase 3 contract of accepting risk smartly. So that's the key, is making sure as our launch tempo and launch cadence is increasing, that we're using our resources to mitigate the most important risks, and we're using our resources smartly. So that's where the risk definitions come in for us.
Oh, that's excellent, because a tailored approach, as you point out, that lessens the workload on your limited team, right? The spaceport is small, you can't be everywhere all the time. So this tailored approach is good for the launch customers as well as the launch team.
And we have analytics to show, these are things that we should look at every time. These are the more high risk, the more prone to failure components. These are the ones you don't need to look at every time. So continuing to learn and continuing to do it more smartly.
Excellent. So 2 lanes, and one of those lanes has 4 tiers.
Yes.
And there are multiple providers within both of those lanes and all of those tiers. Can you give us a little snapshot of where we are with our launch provider sort of bench?
Yeah, this is a really exciting time to be in launch. We use launch as a service in the Space Force. So we contract out the service, we're not buying the rockets. The reason we can do that is because the commercial industry for launch is so robust and so strong right now. So specifically for the national security space launch contracts.
Okay.
So Phase 2, the one that we're still executing, has 2 providers on it. So that's the one that we awarded, about 5 years ago. Phase 3, the heavy launch, medium to heavy launch industry was becoming even more healthy. So in the no-fail lane of Phase 3, we've expanded that to 3 providers now.
Okay.
So we've got SpaceX, ULA, and Blue Origin.
Excellent.
In the more risk-tolerant lane 1 of phase 3, we have now onboarded 5 providers. And the way lane 1 is set up is it's an indefinite delivery, indefinite quantity contract. So we essentially on-ramp companies to be able to compete for task orders in that contract. And our acquisition strategy is to on-ramp annually. So as more and more companies become able to do these medium to heavy lift missions, we don't have to wait 5 years for the lane 2 contract for them to compete. We can onboard them onto lane 1. So with our first onboarding, we had 3 companies. And then just about a month ago, we onboarded 2 more companies for our second annual. Now, when we go to the smaller launch, the Rocket Systems Launch Program, in our suborbital contract, we've got 5 providers. And then in our smaller orbital contract, we've got 12.
Wow.
So there's a pretty wide range to give us assured access to space now.
Now that's excellent. We've always advocated at the Mitchell Institute for launch provider diversification. We believe that the competition helps drive down costs, which I think we're seeing. It also helps minimize any single points of failure if there's a problem with a component that maybe isn't shared among all of the launch vehicles. And then having multiple paths also increases your confidence that you can get your payload to orbit at some point. But from your perspective as a PEO, and maybe PEO is the wrong hat, but from your perspective, in one of the 3 hats that you're currently wearing, how would you describe the importance of launch provider diversification?
So the diversification, you really hit on 2 important things there. The first one is competition. So, all with my PEO hat on right now, the competition is hugely important for us. One, for affordability. So we've seen competition spurring on added innovation. The innovation is driving costs down, not just in the commercial market, but we're really realizing those savings for national security as well. The second reason that you alluded to is really for resiliency. So within assured access to space, we have a list of principles, and they're kind of our guiding pillars for all of the decisions we make, whether they're acquisition strategy decisions or how we're going to use our resources. And one of those is diversification. So we look at diversification of companies, which you alluded to.
Right.
The reason for that is because if something happens with a company, they become unstable or insolvent, we have other ways to get to space. But the diversification for us goes beyond that. So we also look at diversification of the rockets themselves. So if we have an anomaly or a grounding event, a supply chain issue that would impact a certain rocket, if a rocket blows up on its pad, then we can pivot to another family of rockets.
Right.
We look at diversity of components. We don't want all of our rockets to use the same widget, right?
Sure.
The same engine, what have you. But we also look at diversity of supply chain, diversity of logistics routes and logistics nodes. So anywhere we can make sure we're spreading out so we don't have single point of failure adds to our resiliency. And again, going back to the fact that we're assured access to space, the resiliency is that assured part.
So if there is a problem, heaven forbid, you don't have to stop the entire enterprise because you have another path to go by, potentially. Especially if you find root cause analysis determination, then if you've ruled out the components that are not common, then you can just keep pressing forward.
That's definitely the goal. That's how our acquisition strategy is set up.
That's great. That's great. So the boosters get a lot of attention, but without the range and the infrastructure that supports it, you're not going to get off the pad, right? So can you talk to us a little bit about the state of the launch infrastructure to include the fuel, the payload integration, payload mating, all of that aspect? Can you give us a little insight as to how involved that is and what the current state is?
Sure, it is incredibly involved. I'm going to put my Space Launch Delta 45 hat on
Okay.
now for this question. So for the Eastern Range for Cape Canaveral Space Force Station, that is the busiest spaceport in the world. We launched 93 in calendar year 24, which is incredible. We're seeing about a 30% increase every year in the number that we're launching. So while I'm going to list a lot of things that we're doing to improve the spaceport, I just want to foot stomp that the spaceport infrastructure is supporting more launches than anywhere else in the world right now. So we're not in dire straits, but we always see things that we can do to improve that resiliency that we were talking about earlier. So we have a program called Spaceport of the Future Infrastructure. Spotify is the term that we use for that.
Great.
And it actually encompasses both ranges, so Cape Canaveral and the Western Range with Vandenberg. So we have plenty of capacity for our national security space launch, but national security space launches, depending on the year, is between 5 to 15% of the total launches that each range will see. So the vast majority of our launches are supporting getting commercial payloads to orbit. So where we're seeing the need for added capacity is to be able to continue to support those commercial payloads. What we need for the national security space launch, what we're always looking for is that added resiliency. So capacity for commercial, but trying to beef up that resiliency for national security space launch.
Yeah, that makes sense.
So what we're doing with the Spotify program is first under 5 goals that we've set for ourselves. So we want to be able to, the ranges to launch every day. We want to be able to support multiple launches a day. We want to not have to have what we call critical days. So critical days for like construction folks are like no dig days, right? So those are days when we have critical ops on the range. So we're not going to be doing any kind of intrusive maintenance that might impact some of the range hardware and take that op down. We want to enhance the infrastructure resiliency. And then the last goal is we want to reduce the personnel impacts from the increased launch cadence. And by that, I mean, when you have a rocket on the pad, a fueled rocket, you have a large explosive arc that goes around it, and you clear people out of that arc. So we want to take the people that would normally work in that arc and move their work center somewhere else. So when there's a fueled rocket, they don't have to move. So those are the goals for Spotify. What we're doing to realize those are things like widening roads. So rockets have gotten bigger, they've gotten heavier, they are on the roads more often. For folks that aren't tracking, the rockets basically get on big flatbeds, and that's how they traverse the spaceports.
That's right. Okay.
Just on the roads that everybody drives on. So widening the roads, improving the roads for that, improving airfields, railheads, wharves and ports that we use to bring the rockets in, increasing power redundancy, securing, by securing I mean underground ductwork, our comm lines, just anything that you can think of to make the infrastructure more resilient. So we have an OMB passback that we got for fiscal years 24 through 28, $1.37 billion that we're using for that.
Great.
But the work doesn't stop in 28. So we have a continuing roadmap, always looking at what we can do to improve both the capacity and the resiliency of our 2 Space Force spaceports.
That's excellent. And some of those efforts, like improving the roads, that's not a one-time and you're done sort of thing. Anybody who's driven on a road in DC knows road maintenance is almost a constant project. So you talked about plenty of capacity for national security, but the capacity is being stressed on the commercial side. So what can we do to increase the throughput of our spaceports?
So definitely, right, roads, ports, anything that they would need for logistics. One of the things that we have levied on a requirement for the commercial launch service providers is to go to autonomous flight safety system.
Okay.
So when we use a manual, we call it a flight termination system. That's the system that we have sensors all over that are sensing where the rocket is when it's launching, and we know where the rocket is supposed to be. And if it starts going to where it is not supposed to be, then we can manually terminate that flight. The autonomous flight safety system, the rocket has its own basically sensor suite and knows where it is, knows where it's supposed to be, and can self-destruct. The reason that's important for throughput is when it's the manual system, we have to reconfigure the range for every launch. And the reconfiguration can be pretty time taking a lot of time.
Intensive.
Yes, time intensive, thanks. So some companies have already gone to the autonomous flight safety system. Others are working their way there, but that will be definitely an improvement for throughput. We've also are getting close to having bottlenecks in payload processing facilities. So while those aren't necessarily part of the government-controlled spaceport, it's something that all the payloads have to go through. The Space Force doesn't have organic payload processing capability. We use the same facilities that the commercial satellite providers are using. So looking out into the 26 timeframe, it looked like that was going to be a bottleneck, both for the national security space launches on the Eastern Range and the Western Range. So worked really closely with Congress and got great support from them. So we got a congressional ad in 24 for additional payload processing capacity on the Western Range, and in 25 for the Eastern Range. So we used a commercial solutions opening acquisition strategy for that. The western range has already been awarded, and we're getting ready to enter source selection for the eastern range. A couple other things that we need to address, probably the main one after the things that I've listed is commodities.
Okay.
So as rockets are getting bigger, they're using more commodities. So helium, nitrogen, liquid oxygen, the things that you need to be able to launch a rocket. So going back to diversification, we need more diversification of where the commodities are produced, how they're transported to the launch pads where where they're needed for the launch operations. So that's something that a lot of launch service providers are individually looking at to find alternate methods to make sure that they have the commodities when they need them.
Excellent. So you've talked about Cape Canaveral being the busiest spaceport in the world, which is an incredible distinction. You've talked about Vandenberg. They both have their own sort of unique benefits of why the Cape is so busy and why Vandenberg is so unique in terms of the orbits that it can launch into. Can you talk a little bit about why it's so important to have those two, and do we need even more?
Mm-hmm. Sure. So Cape and Vandenberg are very unique in our nation. They're absolute national assets for us. So first of all, they're both coastal. So for space launches, you don't typically launch inland, you launch over the water.
Right.
Because when you do launches, your first stage will re-enter. If there is an anomaly, you could have debris re-entering, and you don't want that falling down on top of people. So that's why we like the coastal launch sites that launch over the water. When you look at geography and a little bit of orbitology, Vandenberg is really uniquely suited for polar launches because they can launch essentially straight south and hug that coastline to get into a good polar orbit.
Okay.
Cape Canaveral on the eastern range, if you are launch in an eastern direction, you get that added velocity boost from the Earth's rotation.
Right.
So launching east is always a benefit as far as your thrust needs. Also, the closer you get to the equator, the greater that relative velocity is going to be. So, being farther south in the CONUS is a good benefit there. So we can do, the equatorial launches. We can also do the high inclination or the polar launches from Cape, but it's really sought after for those equatorial launches. Another benefit of being coastal is a lot of the CONOPS that the launch service providers use now or are going to use are recovering the rockets on barges out in the water. Mm-hmm. So those barges have to come back to a port. So when you're coastal, that makes that transportation a lot easier. Both Cape and Vandenberg are more historical launch sites, so there's a lot of existing infrastructure, which really reduces the cost barriers to entry for launch service providers when they're coming. They're military bases, so we've got security already in place. And a really strong aerospace workforce also, which I think you really can't underestimate when you're looking for those sites. We do have other sites that we launch from. So the Rocket Systems Launch Program has launched from Kodiak, Alaska, Wallops, Virginia. We actually do get an annual congressional ad through that program to boost up the infrastructure, both at the launch sites at Kodiak and Wallops. Those aren't used nearly as much. They're not nearly as busy as the Cape and Vandenberg, but definitely good alternatives to have. The only other CONUS site that does vertical orbital launches is SpaceX's Starbase in Boca Chica, Texas. But there is also some good international partnership opportunities. So we've been talking to some of our allies and partners about their launch capability, whether it's existing capability. So for example, Japan has existing capability. Rocket Lab is launching out of New Zealand, Ariane Space out of French Guiana, and then more emerging capability with Norway, UK, Sweden. Wow. So talking to these partners, definitely if they have existing capability to, start those conversations, see what we may be able to do for enhancing each other's resiliency. And then if they're an emerging spaceport, talking about, how can we design the spaceport so maybe it does become more interoperable in the future? Like, can we design that in? So we're at the very early stages of that, but I'm really excited about building those international partnerships.
That's really exciting. I mean, space has really grown in recent years, and it's wonderful to see the international community coming on board. It's not just a monopolistic view of the United States. It's we have to work in partnership with these other countries for all of our benefits. So that's really great to hear. You talked a little bit about this earlier with the expansion of roads, as well as putting power lines, for example, underground. But we did a workshop here at the Mitchell Institute back in October looking at ensuring an enduring space power advantage. And we threw at our participants a scenario of a hurricane coming through Central Florida, which does happen from time to time.
Yeah.
But in our scenario, we said, okay, we're going to disrupt the launch manifest for 3 months as a result of the damage that's sustained by this. But you're taking a much more proactive approach here and trying to prevent that level of catastrophe from happening. Not that you can prevent hurricanes, but you can minimize the impact of the hurricanes. So can you elaborate a little bit more on what you're doing out there? And Vandenberg in California has earthquakes as well. So what are you doing to help minimize the impacts of natural disasters?
So that's something that we're definitely incorporating into that Spaceport of the Future, the Spotify project that we're working, thinking about hurricanes on the Cape and, as you said, earthquakes, but also wildfires at Vandenberg.
Of course, yes.
So I'm just going to talk about it from a Cape standpoint with my Space Launch Delta 45 hat on. So, where possible, we build to hurricane standards, put as much underground as possible, especially when we're talking about power.
Right.
And then making sure our roads, our buildings, our ports are in good repair. So when those winds and that storm surge, because the storm surge is what we're really concerned about when that hits, you're not going to see things washing away. But it's not just physical infrastructure for us. So we also exercise this. At Space Launch Delta 45, we do a hurricane exercise every year before a hurricane season hits for the non-Floridians. That's June 1st when it starts. So we did our hurricane exercise about 2 weeks ago. So we go through actually buttoning up the base to get ready for a hurricane. And then we go through the post-hurricane recovery actions. So we practice that. There's other exercises that we do too. So we do what we call an ERIE, Energy Resilience Readiness Exercise. We've done a series of those in the past couple of years to understand if there's issues or separation from the power grid, how are we still going to be able to operate? How are we going to recover from that? How are we going to make sure that we're able to shut down safely if needed? And then we do the same thing, that was for energy, we do the same thing for water. So this year we're launching into more water resiliency exercises. So a real world example, we had Hurricane Milton, direct hit right over Cape Canaveral last October. Fortunately, it was just a Category 1 hurricane. I say just, I mean, it's still a legit hurricane. So with the actions that we took going into Hurricane Milton, we were able to bring the range back up to green, so fully mission capable within 24 hours.
Wow.
And we actually launched NASA's Europa Clipper within 72 hours.
That's great.
Could have launched it earlier if it needed to go earlier. So, we've seen with the Cat 1, what we're doing is effective. The exercise is effective. The steps that we've taken so far with infrastructure is effective.
Oh, congratulations. So you've talked about the launch as a service, and you've talked about the capacity demands on a commercial launch, but the Space Force's role doesn't stop for these commercial launches. You still have an active role. So can you describe for our audience a little bit about what it is you do differently for a national security launch versus what you still do for a commercial launch?
So what we do for every launch, to include the commercial launches, is provide the spaceport. So what goes into a spaceport? That's all the infrastructure. So like the infrastructure that we're talking about upgrading, the roads, the ports, the airfields, power, water, all of that. So we take care of the infrastructure. We provide security for the bases. We do logistical support. So there's a lot of transportation to get ready for the launches, whether it's the rocket moving to where it needs to be, the commodities being funneled to the pad. We coordinate all that so the launch service providers aren't conflicting with each other on that. But then as we get closer to actual day of launch, we do the safety calculations. So that is a massive effort, but it's one of the most important things that the range provides. So the range is making sure that the public is safe during these very hazardous operations that we're doing. So we do the safety calculations to understand where the blast danger area is going to be, where we need to clear out air traffic, where we need to clear out maritime traffic to make sure that there's no risk to the public.
Okay. And
then the range, so we talked about the flight termination system. So, we're tracking the rocket, we're tracking the range hardware. If it's not autonomously terminable, then we've got people sitting on console monitoring all that to terminate if needed, which is not a common occurrence. Let me just say that. So other things, we've got a lot of our defenders, our security forces troops out in the spaceports during launch, making sure that nobody's getting inside of those blast danger areas. We've got the fire department standing by. We've got explosive ordnance disposal standing by in case there's an anomaly they need to respond to. And then, ultimately, we've got a blue suitor, either military or civilian, that's going to be the launch decision authority from a range standpoint. So not from the rocket standpoint, but from the range standpoint, saying, okay, the range is ready to go.
Okay.
For the national security space launch launches, we do all of those things, but we're doing the added mission assurance that we had talked about.
Right. Okay, that's great. So it's a bit of a far cry from Uber, where you say, I want this satellite in orbit, or someone else wants this satellite in orbit, and you just kind of sit back and let it happen. You're actively engaged in both sets. That's great.
I mean, it's becoming more normal because we do, at Cape Canaveral, we'll launch 3 times a week. Sometimes we'll launch a couple times in a day. But you do always have to remember like the power and the hazards that come with that rocket.
Yeah, amazing. So we talked earlier a little bit about the launch manifest, but can you describe for our audience how that's put together? How do you decide what launches when and on what booster and from what port?
Yeah, it's a very involved process.
I can imagine.
So first we look at the requirements for the individual satellites. And this is kind of the same thought process as the one I described when we were talking about risk posture. So how critical is it for that satellite to get on orbit? What's the health of that constellation? When does it need to be there? But then also the physical requirements. And the reason the physical requirements are becoming more important, when I say physical requirements, like the mass, what orbit it needs to get to, is because for smaller satellites, we can do multi-mission manifesting, where we're putting a bunch of satellites on top of one rocket. So that's a whole added piece into manifesting now, is essentially bundling missions into one, figuring out what missions can be multi-manifested together. So we're getting the most efficiency out of every rocket that we're procuring the launch service from. So once we know what those mission sets are, now we need to assign the missions to a rocket. So we do that as part of the program office. So things that we need to remember there is any unique interface or performance requirements that the satellite would need from the rocket, the contractual split that we have in that acquisition strategy. So for example, with the phase 2 contract, it's a 60-40 split between the 2 providers. So as we're assigning missions, we need to make sure that at the end of the assignments, it comes out to about 60 and 40% per the contractual requirements. We also are considering costs. So not all rockets are going to cost the same. So by changing this satellite to this ride and this satellite to this ride, you may be able to have more cost effectiveness and cost efficiency. So just from a Space Force standpoint, that's what we're doing internally. Once we've got all that figured out, then we actually go into the manifesting process. So we do that jointly with NRO and NASA. So looking at everybody's need dates, everybody's rocket requirements, and we put those usually into about a 2-year out schedule. And then when we talk about the day-to-day manifest, that's where we're plugging in the commercial missions among all of those.
Wow, it's certainly involved.
But so one important point, I said we started 2 years out, and that's true. But we do have flexibility built into our contracts. We actually have pre-priced options to accelerate and to make us more flexible. So there are, on-ramps in that process where if you have, I didn't know this was going to need to launch 2 years ago, but now we've got to get it in there. There's ways for us to get that in there. So we're not slowing anything down. We've built in the flexibility.
No, that's excellent. So that's my next question is actually about the flexibility, because when you talk about multi-mission manifests, for example, and if one satellite doesn't get ready in time, that could disrupt the entire calculation of the mass and the loads and the balance for the booster. I've often advocated for many years now that we need to have a more placarded approach to saying, if you're within this weight, you can go, and to improve the capacity of our launch cadence. And you've demonstrated that now with the rapid response trailblazer, where you actually changed out payloads rapidly. Can you tell us a little bit about that program and what you've learned from it and what that might mean for future launch operations?
Sure. So in the Space Force, we hear a lot about tactically responsive space, and that's done more on the small launch side. So like the Victus series, Victus Nox, Victus Hayes, Victus Sol. So we took a look in the Assured Access to Space portfolio and said, well, I think we can do this with the larger lift. I don't think it has to be limited to small launch. So we looked for an opportunity and found it with December 24 launch, where we were able to essentially remanifest a GPS mission. So what is normally that 2-year process that I described for integration and figuring out the manifest, in that case, with the Rapid Response Trailblazer is what we called it, we shrunk it down to about 4.5 months.
Wow.
So we're doing it again. We're going to be launching another one in May, and this time we shrunk it down to about 2.5 months. So that's from the time that we say, okay, this satellite's going on this booster, put it on contract, to the time that the satellite is in orbit. So, I know from an aircraft standpoint, 2.5 months may not sound very rapid, but, in just the course of about 6 months, we've taken it from 24 months down to 2.5 months. So that doesn't work for every mission, but the things that we're trying to work with the space vehicle program offices as we have these considerations is, can we build in that flexibility? So some, I already talked about, we've built in on our side the ability to accelerate launches. So that's already pre-priced options on our contract to accelerate launches. Integration standards is a huge piece of this. Absolutely. So if a satellite has a lot of unique interface requirements, whether that's due to its geometry or due to power requirements, that increases the amount of time that you have to design that interface between the satellite and the booster. So there goes your responsiveness. But if you can integrate to standards, that makes it a lot easier. If you can procure adaptive hardware ahead of time and maybe have some of that on hand, that gives you a lot more ability to be flexible. So not every satellite is going to need to be able to launch responsively. But for the ones that are, these are the conversations that we're having with the satellite program offices to say, if the design doesn't have to be, with a lot of what we call mission uniques, if you can have that hardware on hand. For the multi-manifested missions that you brought up, definitely harder there, but what we're trying to do is make sure we understand what the core payload is in that one. So which one, are we basing the schedule off of? And if you're not ready when that one's ready to go, then maybe you need to have a mass simulator that we would add to that stack.
Basically ballast.
Yep.
Right, okay. So your change of command is coming up in about a month or so.
Yep, next month.
Not that you're counting days or anything, but can you look back a bit for us and in the multiple hats that you've had, what has stood out to you as some major positive changes that have occurred under your watch for assured access to space?
So I think with my PEO hat on, executing the acquisition strategy for National Security Space Launch Phase 3. It's not a strategy I came up with. Smart people before me developed this strategy, but actually seeing it work. So where in Lane 2 for those no-fail missions, we've been able to go to 3 providers now. And for Lane 1, we're seeing more providers. It's not just the 3 providers that were on Lane 2. We're on-ramping more providers. So we're seeing the ability of the government to have these relationships and start building up the confidence in more of these rockets. So we will have more options for more resiliency. And then with my Space Launch Delta 45 hat on, we have just gotten tremendous support for our infrastructure needs. In the last couple of years, we've really seen that ramp up between congressional ads, the OMB passback. Everybody is always asking about the status of infrastructure and how they can help. So because of that, we got much needed investment for that capacity for the commercial side, but then also that resiliency for the national security space side.
Excellent. When you were describing what you do for all launches, you mentioned defenders. And so the Space Force doesn't have defenders, but the Air Force does. And so there's a tight partnership between the Air Force and the Space Force within the Department of the Air Force. Can you talk a little bit about the relationships for launch that you rely on with the Air Force or other services or agencies?
It's an incredible partnership with the Air Force. So the 2 Space Force spaceports, so Space Launch Delta 45 at the Cape and Space Launch Delta 30 at Vandenberg, we are about 90% airmen and about 10% guardians. Because we have those massive Air Force squadrons that we really need to keep the spaceport running, the civil engineers, the defenders, the logisticians that are running the airfields, taking care of the vehicles, the weather airmen. I mean, you can't run a spaceport without that Air Force Space Force partnership, and it's been working extremely well.
Excellent. So let's talk about some other partnerships. The University Partnership Program, and I know this is a topic near and dear to your heart. You are the co-champion for Purdue. Can you tell us a little bit about what the UPP University Partnership Program is and what struck you about the relationship, particularly at Purdue, that gives you hope for the future?
Yeah, it's a great partnership. So it's a way for the Space Force. So they've picked about 14 universities, colleges that they're going to have, I'll say, a special relationship with. And it signed active duty guardians to, interact with these schools. Right. There's not, no specific guidelines on, these are your 6 objectives. But we do get insight into the research that the school is doing and try and inform the school on some of the things that the Space Force may be interested in. We interact with the faculty, we interact a lot with the students. So part of that is educating students about the opportunity to join the Space Force if they want to,
sure.
But just the space industry, STEM at large. Purdue obviously is a great school for that because they have an incredible engineering program. Purdue uniquely has the DCTC, the Defense Civilian Training Corps, which is similar to ROTC, but for civilians. So as part of my UPP relationship with Purdue, I get to work with the ROTC cadets and go out, see what's on their mind, have conversations with them. But I do it with the DCTC students as well. So there's just tremendous ways to partner with the schools and make sure they understand what the Space Force and national security space is all about. But the students are incredibly smart. I mean, the research they're doing, the questions they ask. There's a club at Purdue that it's just not even all ROTC students, just normal students that they get together and talk about national defense.
Wow.
Just for fun. And the depth of questions that they have and the way they're staying on top of like geopolitical events, it's amazing. So, as we were talking earlier, I think we're in very good hands when these students graduate and join our workforce.
That's outstanding and great to hear. We also talked a little bit about that some of them are developing their own rockets.
Yeah, it's just
as
for
a college
fun.
student,
yeah,
for fun.
just as a club activity, it's amazing.
That's incredible. Well, thank you so much for your insight and for this great discussion. We're now at the point in this session where we're going to open up for audience Q&A. So by now you know the drill. Aiden will call on you, then please unmute your mic and please state your name and affiliation before asking your question. Or you can submit your questions via the Q&A function. So with that, Aiden, who do we have up first?
First we have Greg Hadley with Air and Space Forces Magazine.
Go ahead, Greg.
Hi, can you hear me?
Yes.
Thank you so much for doing this, General. My question is about infrastructure and specifically the contract you referenced for Astrotech on the Western Range to expand their space processing or their space vehicle processing facilities. Can you explain a little bit more about what that money is going to, what kind of facilities, and what kind of goes into the process for processing those space vehicles?
Yeah, so I won't get into anything proprietary, but the way the Commercial Solutions opening competition worked was we offered a public-private partnership. So we got a congressional ad on the Space Force side of the house. Astrotech also is putting some of their own funding into invest in this expansion. So it didn't have to be a facility expansion. Companies could propose other ways to increase throughput in processing capabilities for spacecraft, but Astrotech is expanding a facility that they have existing out in Vandenberg. So what this will do for us is basically relieve at least the near-term bottleneck. Who knows where we'll be in 20 years as far as the need for spacecraft processing facilities, but because it's something that every launch, we're not going to launch if there's not a spacecraft, and the spacecraft has to be processed. When we talked about the multi-manifested missions, that's really what's between that and the increased ops tempo is what's driving the need for that added processing capability. So before, 10, 15 years ago, we had one rocket and one big satellite on top of it, and the satellite needed a bay for processing. Now we may have a rocket with 4, 5, 10 satellites on top of it, and they may all have different cleanliness requirements for processing, different security requirements, so they may all require different bays. Yeah. So that's really what's driving up the need for processing and creating that bottleneck. So this was a hugely important congressional ad for us to be able to execute to relieve that bottleneck on the Western Range.
And when you talk about satellite processing, the satellites all have to get to that port somehow via air or via road, but when they transport, they're empty. They're not filled with fueled, right? But they are fueled when we launch them because we don't have an on-orbit refueling capability now. So part of the satellite processing that you're talking about is checking out the satellite, fueling it, making sure that it's stacked, and it also is the encapsulation.
Encapsulating it, yeah.
And then that encapsulated module is brought out to the launch facility and stacked on the booster, right? So,
Yep, so
all of that's part of that contract?
No. So the AstroTech contract is the processing itself. That's where the fueling will occur.
Okay.
The transport, that's logistics that the launch service provider would be coordinating.
Okay, very good. Thanks for the clarification. Aiden, who do we have next?
Next, we have Stephen Clark from Ars Technica.
Go ahead, Stephen.
Hi, General. Stephen Clark, Ars Technica here. My question is regarding Seabased Launch. I've heard some recent discussion in industry that maybe it's time to look again at Seabased Launch. China is doing it. U.S. tried it before the Sea Launch, but it didn't last. Curious, from the government perspective, are there any efforts underway within Space Force to study Sea-based launch as a strategic capability for enabling, resiliency, flexibility, or is this an area where you're stepping back, and if industry wants to propose something, you might be interested, but
We just lost our audio
So
for the question.
I
but-
think I got the question, the gist of it, so I'll go ahead and start answering. So it's something that we're interested in seeing what the possibilities are. I actually had a meeting last week with a company that's looking into developing a sea-based launch capability. It gives you great benefits when you think about being able to launch from the most advantageous spots to get to the orbit you need to get to. Could potentially relieve future congestion, especially as we're seeing more and more commercial missions come online. So there's good benefits to it. It's been tried in the past, outside of what China's doing, it's been tried in the past here, and the business case just hasn't closed. Right. So the questions that I've been asking the commercial companies that are looking into this now is, first, how will that business case close? Or are you looking for the government to purely fund this capability? We buy launch as a service. That's a great acquisition model for us. So if there was a possibility of looking at a sea-based spaceport as a service, that's something I would definitely be interested in understanding how that was going to work. So there's nothing available right now that we could just go out and put onto contract, but we are talking to some of the companies to understand, one, how does the technology work? How do you see the logistics working? Because you got to get everything, we talked about the commodities, you got to get the commodities, the rocket, everything encapsulated out to the barge, essentially. How does that work? But then also, how does the business case close?
Yeah. So for the smaller launches, and maybe this is part of the RSLP, you could even do air launched, and we've done that in the past. Is same question, I guess, basically, for the air launch side. Is that something the Space Force is looking into?
So that's actually something that we've already done under the Rocket System Launch Program. We did have an air launch orbital provider in that contract. So we're not opposed to it. Okay. Companies can provide whatever capability they have to get to orbit, and as long as they meet the weight requirements, the orbitology requirements, we are definitely happy to have them compete.
Great. Thanks for that clarification and answer. So Aiden, hopefully you can hear us, and who's up next?
Next, we have Shelley Mesh from Inside Defense.
Go ahead, Shelley.
Hi, thank you for taking some time to answer some questions. I wanted to kind of expand on launch locations. Could you talk about whether you're looking at international partnerships for locations for launch? Is that something that you see as near, mid, or long term?
So we are looking at international partnerships, as potential ways to get our satellites to orbit. I wouldn't say it's necessarily near term. So near term, we've got our Rocket System Launch Program, we've got the National Security Space Launch Program meeting our needs. But as we're looking at increasing the resiliency, increasing the ways that we have to get assured access to space, that's where these initial discussions with our international partners are coming in.
Great. Aiden?
Our next question is from Audrey Decker with Defense One.
Go ahead, Audrey.
Hi. General, thank you so much for doing this. I have a question on Rocket Lab and Stoke Space being onboarded to NSSL Lane 1. How close would you say are these companies to actually, launching their rockets? Like some analysts have said, it could be years away. So I guess when do you think these companies might actually be able to compete against, SpaceX, ULA, Blue Origin? Thanks.
So the contractual requirement to be onboarded is that you have to show that you have a credible plan to get to that first launch within 1 year of the request for proposal coming out. So as we assessed the proposals that Stoke and Rocket Lab provided, by means of the fact that they're onboarded to the IDIQ now, you can tell that we assessed that their plan was credible to get to that first launch within a year. So we would expect in less than a year that they would have their first launch, and then after that be able to compete for task orders.
Wow. So the different lanes and RSLP and NSSL that you described, and you said 12 providers, I think, for RSLP.
RSLP, yep.
Are all of those, have they all launched, or are they still in different stages of development?
So there's different stages of development. I mean, just looking at National Security Space Launch, as she mentioned,
Right.
we have Stoke that they're constructing their pad, they're doing great work developing their rocket. Haven't seen that first launch yet. All the way through, ULA, a really historic provider, SpaceX, a very prolific provider. So we run the full range. And that all goes back to risk tolerance, right? That's
Sure.
the varying risk tolerance levels. What allows us to do that and have that acquisition strategy.
Great. Aiden, who's up next?
Next, we have a write-in question from Arthur Stevens. He asks, for the Cape especially, we're starting to see multiple launches a week, and that might soon be one a day or even several a day. How's the Space Force working with the FAA and other agencies to minimize the impact on the airspace, maritime traffic, et cetera, as the rate of launch increases?
So we do partner very closely with the FAA. Most of the launches that are coming out of the Cape, when they're commercial launches, are FAA licensed. So you'll see a difference between now and maybe 3, 4, 5 years ago, as a lot of our launches are at night, like in the middle of the night. That's when the air corridors are less busy. So that's one of the ways that they're decreasing the impacts. For every launch, we put out the NOTAMs and NOTMARs, so the notice to airmen and the notice to mariners, so they understand exactly when the launch is going to be going to help clear out that traffic. But we do work very closely with the FAA in making sure we're meeting their timelines. They know what the manifest is, and we're able to find those windows that will work for everybody.
So windows, we typically think of windows for the customer. That the satellite has to go into this specific orbit, and maybe there's only certain times of the day when you can reach that. Or if you're NASA and you're trying to get to Mars, there's only some finite windows. But then to have to deconflict that with also air traffic or maritime traffic, a lot of moving pieces.
A lot of moving pieces, and add Florida weather on top of that.
Yeah.
We've got an absolutely exquisite weather squadron that can find like very small gaps in the hull. So maybe you have a 2-hour launch window, and they'll say, okay, in 75 minutes, you're going to have a 15-minute gap, and they can do it with enough fidelity that the launch service providers can make the decision to go ahead and fuel and press towards that launch. So
That's incredible.
yes, there are a lot of moving pieces.
Great. Aiden, who's up next?
Next, we have a question from Morgan Park. He asks, could you discuss how Spaceport Access and facility leasing work at Vandenberg in the Cape? How does the Space Force balance providing access to new entrants while still incentivizing incumbents to make strategic investments in infrastructure?
So for the access to new entrants, as we have launch real estate, so existing launch pads that don't have an occupant on them anymore, or greenfield areas that we're looking to develop into launch pads, we do what we've called like a launch pad allocation strategy. And there we're looking at making sure we have assured access to space, making sure we have the diversity of companies, of launch systems. But we also want to make sure that we are promoting a strong industrial base, because the Space Force and the DoD and the government get huge benefits from that. So there's a lot of different things that we're looking at. the way we've done, just baselining the last one that we did out at Cape Canaveral, we put out an RFI, or request for information, to industry to make sure we understood all the companies that would be out there, the different rockets that they may want to have a home there. We also are looking specifically at the geography. So some pads are good for a large rocket because they have a lot of distance between neighboring operations. Some pads are kind of wedged in there pretty tight, so they'd only be appropriate for a small rocket. So we're balancing all of these things when we're making our leasing decisions. In our leases, we can also have gates to make sure that we are leasing to companies that are actually going to have output from that pad. So that's another thing that we consider in the leasing decision is the company financially able to put the investment into the pad? Is their rocket close enough that it's going to be launching in the near term? But then with the lease, we can say, okay, if by, to your point, you haven't started construction or you're not well on your way with the environmental studies, we have the option to take those licenses back. When you asked about the more established companies, we can do 20, 25-year leases, and that really helps them. In the case of a company with investors, it helps their investors see the long-term benefit of investing into that, the pretty expensive infrastructure development that they'll need.
Great, thank you. Great answer. Aiden, I think we have time for about one more question.
Great. Nate Kirk from Perry Labs asks, what value do you see in the SpaceWorks Digital Spaceport of the Future effort that has been ongoing since July 2024?
So, I think anytime you're going to digitize, there's benefits in that. But it's a very, very complex effort. There's a lot of things that need to be brought into there. There's a lot of aspects of the ranges that aren't digitized at this point. So before you can even bring a lot of things into, one centralized program, there have to be other upgrades that happen to enable, different data streams, whether it's from infrastructure or security, to be able to connect to that. So it's not as simple of an effort as it may sound on the top layer. So a lot goes into that, but I think there's a lot of benefit to be reaped from it as well.
Excellent. Well, General Panzenhagen, thank you so much for your time today and your insight about launch and PEO, and congratulations on completing a successful tour, and look forward to seeing what you do next. And so, ladies and gentlemen, we've come to the end of this Schriever Spacepower series. Thank you again to General Panzenhagen for taking the time to talk with us, and to our audience, thank you for joining us for this discussion. And from all of us at MI Space, have a great Spacepower day.